Sup, Mr. Lee here. All right, this practice is on recognizing functions. So telling if a graph or a table is a function or a non-function. Okay. So first of all, our definition of a function, it's going to be any relation that includes x values with exactly one y value. Okay, so each x value must have exactly one y value. That's what a function is. If you have an x value that has more than one y value, then it's not a function. Okay, so you'll be hearing me say this definition over and over in this video. Okay, so I have the two exercises side by side. It's good to see them both playing at once. Left is on the graphs, and then right is the tables. Okay, so every x value must have exactly one y value. Let's see what we got here. So on the graph, does the graph represent a function? This would be yes. Every x value has exactly one y value. X value of -3, one y value. X value of 0, 1. X value of 2, 4. X value of 3. X value of 5. You guys see what I'm doing here? You guys might also be familiar with the vertical line test. If you draw a vertical line through any of these x values, it should only hit one point, right? Only hits one point there. Another vertical line only hits one point there. Another vertical line only hits one point there. Okay, so you guys can draw your own vertical lines if it helps you. Okay, let's compare it with a table. Okay, I'm going to mix and match here because it's the same definition. All right, so I have x values on the left here. It's like a table, and then y values here. So does every x value have exactly one y value? I'm going to look for duplicate x values. Okay, so 150, I don't see any duplicates. 220, I see a duplicate here. Okay, be careful here. We have a 220. Let me highlight this. Let's see if this works. So I have a 220 and a 200, and I also have another 220 and a 200. So this is actually okay because it's the same point, right? You have an x value of 220 that produces the same y value each time. So that's actually okay, right? Because it's the same point. Only if it produces two different y values, then we have a problem. So this is still a function, okay? Let's see what else we got here. So let's see, 370, is there any duplicates? No. I'm still looking at the x values. 290, I don't have any duplicates. 300, I don't have any duplicates. 200, I have no duplicates. So this one's actually still a function. The only duplicate x value I had was 220, and it produced the same y value, which means it's the same point. We're not producing two different y values, so we're okay. All right, so I'm going to go ahead and click yes on that one. That one's also a function. Okay, I'm going to go back to the graph. Let's see two new examples here. Okay, so this one would be a non-function. Okay, go ahead and draw a vertical line anywhere in this kind of middle region, right? It's going to hit 1, 2, 3, 4 points. If I just focus on the x value of 2, okay, going to my origin, x value of 2. This x value of 2 has more than one y value. It has 4 different y values, okay? So vertical line test says that's a no. To the table. Let's look for any duplicate x values here. 65 has a duplicate, 65, 20, and 65, 18. Already, look, we have 2 different y values. So I can discount it as a function. I don't need to check the rest. You could if you wanted to, but this is already a non-function. Because a single x value had more than one y value. Disqualifies it. Okay? All right, this graph is a vertical line itself, so the only line I can draw is through itself, or only vertical line I can draw. So obviously it hits more than one point. It's going to hit all these infinite points. Okay, so this is non-function. The only linear function, all right, the only line that is not a function is when you have a vertical line like this. Okay, so the x value of 6 has more than one y value. It has infinite y values. Back to the table. Okay, this one we have some names, some words here, but same thing. We're going to be matching different x values, or duplicate x values if we find them. Okay, so let's see. Peter does have a duplicate. Peter, president. Peter, justice. So the x value of Peter points or contains 2 different y values, president and justice. We can already disqualify it. We're getting kind of lucky here. The first option shows it's non-function. Okay. Okay, let's do one more. All right, so if I draw a vertical line anywhere on this graph, only hits 1 point. Another vertical line only hits 1 point. Another vertical line only hits 1 point. Another vertical line only hits 1 point. Every x value has exactly one y value. That's what that vertical line test is testing. So that's good. And then last table, do we have any duplicates here? I think we do. Let's start from the top. Does 5 have a duplicate? It does not. Does 8 in the x value have a duplicate? It does. 8, 24, 8, 24. This is still okay, right? The 8 repeats, but then it points to the same y value. So it's the same point. We're not breaking any rules with more than one y value, so that's still fine. 6 has a duplicate. 6, 26. 6, 26. Same thing. This one's a little bit tricky, okay? So the 6 is duplicate again, but then it points to the same y value, 26 and 26. So we're still good. 10, 4, and 7 don't have any duplicates. So this is still a function. Okay? So there you have it. Every x value has to have exactly one y value to make it a function. Oops, sorry. That's my fault. I told you it wasn't a function, but then I clicked no. So let's fix that. Minor error. So the reasoning was still the same. All right, there you go.